Hey everybody. So we are starting chapter 5 looking at animal populations and predator-prey relationships. So we're looking at factors that can change um, the population of a certain species, both living and non-living factors, and how they can cause increases and decreases or just fluctuations in the general population. So we did a modeling activity today. You are, of course, excused from that. And afterwards, we did a worksheet called the Lesson of the Kaibab. Um, this worksheet is going to look at the effects of carrying capacity. So the carrying capacity of an ecosystem is the maximum number of organisms that an area can support on a sustained basis. So we're going to look at what can be the effects on a population if that population happens to exceed carrying capacity, um, as well as what are some both living and non-living factors that could cause that. So there's a little bit of reading here, this background information. Please make sure you read that before we start. There's going to be some follow-up questions, and you're going to pull some answers either directly from this reading for the analysis questions or for the questions that are more your opinion. This will help you to formulate probably a better opinion than maybe if you had started the worksheet without reading it. So in order to start, we're going to first graph the deer population of the Kaibab deer. So over a span of about 35 years. If you do not have a printer at home to print this out, again, you can do this on lined paper. Do your best to draw out some graph grid boxes, or maybe you can find some graph paper lying around the house. And of course, these analysis questions you could just answer on lined paper, just number your responses. So you can still do this worksheet even if you don't have a printer at home. Just do the best you can. I'm going to be more than accommodating. Usually everybody needs a little bit of help to start off with the graphing. Analysis questions can be kind of straightforward since we have that reading to help us. But looking at my data table here, start off at the year 1905 and I end at the year 1939. So when I count my boxes down here, so I do end up having a little more than 40 boxes. So that's going to be more than enough boxes down here where I'm going to put my time to just go by one for the years. So we're going to start at 1905 and we're going to count by ones across until we get to 1939 or 1940. We got 1, 2, 3, 4, 5. So that's 1910. 1, 2, 3, 4, 5. So 15. 1, 2, 3, 4, 5. 20. Etc. down the axes. Over here I have my deer population. So this changes over time. So I'm going to look at my minimum number. So I have 4,000 here. I have a maximum number going to 100,000. And so counting the boxes I have running up along here, if we go here by, let's see, 5,000s, that should be able to accommodate our 100,000 number. So I can start off, I got 0 here, 5, 10, 15. Here is going to be the 20,000 mark. 5, 10, 15, 40,000 mark. 45, 50, 55, we got 60,000. And then from here I can plot my data points. So 1905 I was at 4,000, so that's going to be right under 5. Let's see, 1910 we were here at 9,000, so it's going to be a little under here. And so I'll connect my lines as I go, and you should end up with a graph looking something like this when you're done.